Okay, so while you guys are getting joined up there, okay, all the stuff you're going to need is actually in the class work tab. Okay, the stuff that you're going to need for today and for the rest of the course as well. Okay, it'll take a while to load because some of the files in there are pretty big. Okay, so there's this is just a link to my YouTube channel. You'll probably not need to use that, okay, because every day I'll post the link to the class recording each day in the stream, so you probably won't ever have to directly go to my YouTube channel, but if you do, there's a link to it there. Okay, you don't have to subscribe to that or anything. Okay, I don't make a dime off of that or any of the views that you have on there. Okay, so you don't have to worry about that. Okay, and then the notes and worksheet packages. Okay, those are a big one. If you open that assignment, it's going to take a while for it to load here because, like I say, there's some big files in there. Okay, there's going to be 4 workbook packages, 1 for each unit, and 1 notes package file. Okay, the notes package you will need pretty much every day, and you'll need the workbook package for whatever unit we're on. Now, how you have that available to you is entirely up to you, whatever's going to work best. Some people like to have the pen and paper copy. Okay, if that's the case, go home today and print what you need. All right, so you can see now there's, okay, the files are all there. Okay, so there's the, this is the notes package, okay, the one that has that insignia. The other ones are all the workbook packages. Okay, if you're taking it home to print it, don't print it in color. Okay, it's, by the time you print all that, you're going to be looking at over 100 pages. Okay, you don't want to print that in color. You're going to be going back and forth to wherever you get your cartridges from. Okay, and it's going to cost you a lot of money. But don't do that. Okay, if you're going to print it in black and white.
Can you print it here if we ask you?
I won't print it. No. Yeah. Okay. So if you need it on paper, okay, then obviously you can print it. Okay. But yeah, print it in black and white, or just do what most people do. Okay, and you obviously don't have to do this, but I have a lot of people who just do this on their phone or their tablet or their laptop. Okay, whichever works for you. I don't have a problem with it either way. Okay, but you'll notice that your files don't say student Coder; they say your name. Okay, each of you got your own copy of this as a Google Doc. So you can edit it and it will always stay just yours. Okay, so whatever changes you make will always be stored in that Google Doc, and that was by design. Okay, because there are going to be times where I'm going through something and I'm going to say, hey guys, this isn't in the notes package, make sure you add this. Or, guys, this part's really important. Underline it or highlight it or something. We can do all of that in Google Docs. Okay, however you want to do it. If you need it on paper, then you put it on paper. Okay, but you can also do it just electronically.
And what is the mine from the website? Is it the same? Like, is it updated?
It's updated. Yeah, get it from this one.
Okay.
Yeah. Okay. Plus, this one's in your own name. It's your own file. Okay. It's better off to use this one. All right. So those are things you're gonna need. Okay, starting today. Right? And then the other stuff in there. Okay. Obviously, like we said, the link is already in there, and down here in Physics 20 materials, there's just 2 files. The course syllabus, which I'll be going over today, okay, and your equation sheet. I will give you a paper copy of that. It is the only piece of paper you're going to get from me, okay? So I will photocopy those and then hand them out to you, okay? But we want to try and limit how much interaction we have on paper because, COVID. Yeah. Okay. All right. So we'll go through this here right now, okay? If everyone can just open up the course syllabus, you can kind of follow along with me on that. Okay, before we get to all of this though, the extra kind of COVID stuff for this year, okay? We have my COVID shield here. Okay, that's the green tape on the floor, okay? It is my super special physics force field that protects me from, okay, but all it is just, it's the 6-foot marker. Okay, if I cross over it, you guys have to be masked up, and so do I. If you come to see me at my desk and you cross that line, I mask up, you mask up. Okay, just be on the safe side and follow all the COVID protocols. Okay, obviously when we're like this, if I'm behind the line, you don't have to wear your mask unless, of course, you want to. You're perfectly welcome to do that too. Okay, if you turn around to talk to somebody or turn across to talk to somebody, then the masks come back on. Okay, we all got to do our part on that. Okay. Other COVID stuff, hand sanitizer on your way in, okay, one on the wall, one on the desk, okay, make sure you use that when you're coming in each and every day. And now we have this new and improved stuff, EnviroCare Neutral Disinfectant, dimethyl ammonium chloride, and dimethyl benzyl ammonium chloride. it's going on your desks, okay? It's better than the soap and water solution. So when class is over each day, I'll come around and spray your desks and ask you to grab a paper towel and just give it a quick wipe. You don't have to dry it completely, it does evaporate very quickly, and that's kind of the idea. Just make sure it covers all of the desk, and then let it evaporate, and then the desks are sterile. Okay, so that'll be one of the new ones. Okay, in terms of exiting this classroom, we have special arrangement because we're not very far down the science wing. I'll make sure that we're ready to go at the door when the bell to end class goes. You can quickly turn left. Okay, you don't have to wait for the entire science wing to empty to leave this classroom, but you have to go quick. Okay, as soon as the bell goes, you've got to be out the door and going left because people will be coming around that corner, coming towards you, and we don't want the face to face. Okay, but you can turn left out of here if you go fast. Please use the closest bathrooms if you have to leave for the bathrooms. Okay, girls is right across the hall, boys is just down the hall. Okay, and the nearest water fountain is just past the biology lab, although it's probably better if you bring water from home during all of this, but obviously there's water. Okay. Questions on any of that stuff? Okay. All right, so the classroom policies for this class, guys, obviously attendance is going to look a little different now in COVID. Okay, but obviously being here or being here virtually is important. Okay, if you miss class, you're going to get behind pretty quickly. So if you're here, obviously it's easy. You're here and you get everything. Okay, if you're away, okay, for a short period of time, like a couple of days or something like that, then make sure that you are following along on Google Classroom, because each day I will post what we do in class on Google Classroom. That'll be the recording of the class, which I'm doing right now. Okay, the microphone is right there, right? So it records what I say. It also catches your questions as well, okay? And what's on the smartboard, okay? So if you're not here, you're gonna watch that recording because it'll be posted in Google Classroom, okay? Unless we have to have, you know, a fairly significant chunk of the class out for self-isolation. If that's the case, then I will live stream, okay? But if it's like, you know, one person is absent because they've got a doctor's appointment, I'm not live streaming. Okay, I'll live stream if we have to, okay, but I don't like to have to, right? So if you're away, check Google Classroom for that class recording, watch it, and then come back with questions if you have them, okay? It'll tell you everything we did in class, except you don't have to look at my ugly mug because there's no camera. All right, so make sure that you are staying caught up, okay? You're responsible for anything we do while you're not here, okay, including labs. If we do a lab and you're not here, the data or a video of the lab will be posted, okay, and you can get your data from that, and you can still do the lab report or assignment or whatever. It's all going to be posted, okay, so you can do that. Okay, in terms of lates, period 3 is the worst period of the day for lates, okay? Don't be late. Class starts 12:31. 12:21, not 31. 21, okay? That means you should be here at the very latest at 12:20 and 30 seconds. So that you can have your book open or whatever and be ready to go. Okay? If you are getting here at 12:21 and 10 seconds, you will find the door in the closed position. Wait on the other side of it until I come get you, so that you're not interrupting everyone else who got here on time. Okay? Please make sure you're here on time. It's a disruption if you are not. Okay? All right, so all the resources available to you. Obviously, we talked about the class recordings that will be available. Okay, you won't need to go to my YouTube channel, so you can kind of ignore 2.2. You don't need to subscribe. I only have 600 subscribers, and I'm not making a dime. Okay, so you don't have to worry about that part. Okay, but obviously, Google Classroom is going to be super important, but you guys know how to use that already. Okay, everything will be in there, and all of your assignments, lab reports, everything will be submitted electronically through Google Classroom. Okay, if that's something that's pen and paper, then you're taking a picture of it, turning it into a PDF, and submitting it to me through Google Classroom. Okay, we're gonna exchange as little paper as possible. Okay, here. All right, everybody with me on that? Okay. And so, like I said, each day I'll post the day's activities, so make sure you're checking that. Okay. So if you're away, okay, and if you're away for a couple of days or for whatever reason, okay, make sure you're doing that stuff. Because if you come back and you go, hey, Mr. Codere, look, I know I was away for 3 days. I watched all 3 of your recordings, and I worked on the questions from the workbook that everybody else did, and I think I get it, but I didn't know how to do question number 4. Can you please help me with that? No problem. You did your part. Okay, you watched the lessons. You tried the stuff we tried. You did your part. I'll do my part, and I'll help you out. You come back after being gone for 4 days and go, Mr. Codere, what did I miss? I will say a lot. And that's all I'll say. Okay? You're responsible for getting caught up on that, not me. Okay? You do your part and I'll do mine. Okay? But if you come back and say, hey, Mr. Gary, I know I was away for what's the equivalent of like 6 hours of your time. Can you teach it all to me again? No. I'm not going to do that. Okay? I'll help you with whatever part of it you didn't get. Okay? But I can't. I don't have time to teach it again. Okay? So make sure you do that part. And then obviously, guys, if we're live streaming, then it's just like class, except you're looking through the computer at me instead. Okay? How did everybody like that last semester? Oh, some people liked it. I hated it. Because I was looking at a screen and basically nobody turned on their cameras, and I had no idea whether people were even there or whether they got it, right? Like, you don't realize how much of me knowing whether you get something is me being able to see your face. Okay? Because if I'm just staring at the screen, I just assume everybody gets it. I went so fast, okay, during that. Like, I did 4 weeks of class in 3 weeks, easy. Okay? Because nobody ever said, Mr. Gray, I don't get it. And I couldn't tell because I couldn't see anybody's faces. So if we have to go back to the live stream, please have your cameras on, or ask questions and say, I don't get it. There's no shame in that. Okay? But if you don't tell me that, I just assume everyone gets it and it's bad. Okay? All right. For classroom behavior stuff, big thing is just respect, guys. Treat each other with respect, okay? That I will do my best always to treat you with respect. I'm never going to single anybody out and belittle you in front of everyone, okay? I'll save that for, in the hallway. No, okay. I'll treat you all with respect, okay? And I expect you guys to treat everybody in the classroom with respect as well, okay? If I say listen up, that means I need your full and undivided attention. So that's your eyes forward and your ears free of your earbuds and headphones and whatever else. Okay, so it could be, okay, listen up guys, today we're going to talk about Newton's second law. Boom, we're going on teaching. Okay, so just make sure if you hear those words, I've got your full and undivided attention. In Physics 20, there will be two kinds of work. Okay, the kind of work that comes in for marks and the kind that doesn't. Okay, both are important. The kind of work that doesn't come in for marks is stuff from our workbook. So that would be, I teach you about projectile motion, and then we sit down and we work on some projectile motion problems from the workbook. I'm not taking those in. I'm not doing a homework check. I'm not marking those. Okay? Those are for you to have the opportunity to practice, hone your skills, learn the stuff. Okay? With me here to help you. All right? I still expect that they get done, okay? But I'm not checking. The other kind of work is the kind that does come in for marks. That's the stuff you'll be submitting on Google Classroom, lab reports, assignments, etc. Okay? That stuff obviously has to come in for you to get your marks. Okay? Both are equally important. Now, if you're doing all of that, this last part here shouldn't be too important for you. And that would be if you were to achieve a mark of less than 50% on an exam, because that happens very, very rarely. Okay? If it does, then you'll be asked to come in and spend some time with me at lunch working on an alternate assignment to make sure you understand the material that was on the test, and I will help you with that, okay? But there are no rewrites, okay? Just so everybody knows. There's no rewrites in Physics 20, okay? I will give you 2 weeks notice of an exam, okay? That's lots of time for you to study and come in and see me for help, okay? When can you come and see me for help? At lunch. I am here every day at lunch except Tuesday, because I have supervision all lunch hour on Tuesday. Okay? I also have supervision on Wednesday, but it's the second half, so you can come still see me on Wednesdays. Okay? But otherwise, I'm here. Mondays at lunch, Thursdays at lunch, Wednesdays lunch. Come and see me. Okay? And I will help you out, because I have no life. This is where I am. All right. Now, fairness versus equality. This has to do with how I deal with stuff that goes on in class. Okay? I will always try to treat everybody as fairly as possible, but that means I don't treat everybody equally, because believe it or not, treating everybody exactly the same doesn't take into account that everybody isn't exactly the same. Okay? And so I treat most things on a case-by-case basis. So that might mean that somebody gets treated a little differently than somebody else. Okay? If you ever feel I haven't been fair, please come and talk to me after class about it. Okay? Because I do try to be as fair as possible. Right? The example I always use happened about 12 years ago now or so. Okay, I had a class handing in their labs back when we handed everything in on paper. Okay, everybody had handed it in to me except the last 2 people. Okay, and the first guy was just like, he was brutally honest with me. He's, Mr. Guerra, I was like watching the season finale of my favorite show, and I just didn't do it. I'm like, well, you could have lied to me. You could have told me some sob story about why I didn't get it done, but you were brutally honest. Okay, and I said, well, you know, you're still going to take the late penalty, but I'll take it. Get it into me as soon as you can, and I'll still mark it. But obviously, you're going to lose some marks because it's late. Okay, the person behind him was standing, and she was like this, like thought she was going to fall down. She looked like she would have to get better to die. She was that sick, like green. I know we use the expression that person looks green. She was literally green. Okay, yeah. And she's like, Mr. Coder, I'm not doing very good, and I don't have my lab done. I'm like, she's like, are you okay? Yeah, but my parents had this huge fight, and they both stormed out of the house, and then I had to make dinner for my brother and sister, and I took chicken out of the freezer, and I didn't cook it enough, and we spent the whole night throwing up, and I didn't get my lab done. So, because I'm just a bit of an ass, I did point out to her that if she hadn't left it till the night before, that kind of stuff wouldn't happen. So there's a lesson for everybody. Don't leave it for the night before. Okay? But at the same time, it was kind of beyond her control. Okay? I let her have a 1-day extension to get it done without a late penalty. Okay? I think I was fair because this was a person who had never not handed something in on time. Okay? I taught her in Science 10. I had her in Physics 20. Never not handed in something in on time. Totally out of character for that to happen. Okay? So I think I treated them fair. I didn't treat them the same. Okay? And one guy, to his credit, brutally honest, just didn't do it. Okay? The other person had some extenuating circumstances. Okay? Now I'm not saying come up to my desk and make up some story, give an Oscar-worthy performance complete with tears about why it's not finished. Be honest with me. Okay? But yeah, I'll try and treat everybody fairly. Okay, and then lastly, accountability. Okay, make sure basically that you are responsible for your stuff. You get your stuff done on time. Okay, all of that. That's accountability. Okay, in terms of your marks, okay, the first thing about your marks is I won't and can't discuss your mark with you in class. Okay, so when I hand back your material, okay, if you don't like your mark, make sure you listen carefully while I go over the assignment, because I do that every time I hand something back. I go over it in its entirety. Okay, but if you don't understand still why you got the mark you did, come and see me after class and talk to me about it. Okay, and if we're both reasonable, okay, things will be better. Right? You don't want to be like the guy who came up and threw his assignment on my desk and this mark sucks. Yes, it does. Sit down and shut up. You can't come up and confront me in front of 30 other people and think you're going to get your way. Okay? This is my house. I get my way here. Okay? So, yeah, just come up and be reasonable, but do it after class because we don't need an audience for something like that. I can't talk to you about your mark. It's a FOIA thing in front of everybody else. Okay? All right, we'll talk about your marks distribution here in a minute when we go through the syllabus. Okay, assignments and labs are to be handed in on time. Late assignments can be handed in, but they'll be penalized 30%. Okay, here's the reason for that. Okay, first off, labs are due start a class on the due date. So for you guys, that's 12/21 or on Fridays, 10:30. Okay, but start a class on the due date. Okay, I know every teacher's different. Some people like 3:30, some people like midnight. No, start a class on the due date for me. Okay? The reason being, I plan your assignments around when I'm going to have time to mark them, because I will always give you your assignments back the next day, sometimes the same day. Okay? I plan when I take them in around when I know I'm going to have time to mark them, so I can turn them around quickly. Okay? But that means that because I'm turning them around quickly, I'm not going to accept them for full marks if they're late, because then I don't know whether you copied it off of somebody else or just sat there and listened when I went over the whole thing the next day. Okay? Hardly fair for you to get 100% because you didn't hand it in on time. Okay? So just know that's going to be how that will work. Okay? In terms of that. Okay. Questions on that part? Okay. So you're going to get it back the next day, every time you hand something in to me. Okay? 22 years of teaching, I've only failed to do that once. Okay? The day my second son Luke was born, I stand by my decision to hold my wife's hand while she squeezed out a kid. Okay? Totally the right decision. Okay? Had I been sitting there marking labs, I probably wouldn't be married right now. Okay? So, okay? Yeah. But guys, hand holding. That's what you do in that situation, nothing else. Don't take out your phone, okay? She's going to tell you she hates you and all that, but she doesn't. Just, yeah, it's tough, okay? It's got to be tough. Okay. All right, so assessment, oh, sorry, that's on there twice. I don't know why that's on there twice. Okay, so the syllabus here, there's 4 units in Physics 20, Okay, the first unit is kinematics. That has to do with just simple motion. A lot of it's going to be a review. The stuff we go over today is all review from Science 10. Scalars and vectors, v equals d over t, okay, that kind of stuff. There's some acceleration stuff, okay, that'll be a review of Science 10 as well, okay, and there will be graphing, okay, position versus time, velocity versus time graphs. We still use those, still a big part of this unit, okay, and you've done all of that in Science 10. All we do is we build on them a little bit, okay, we take those same concepts and we take them a bit further, okay. One of the ways that we take them further is vector addition, okay, vector component addition. So in Science 10, the extent of vectors for you was forward and backward, left and right, okay, north and south. It was always one dimension. It was positive and negative basically all the time. Okay? In Physics 20, they become two-dimensional. So instead of forward and backward, now you might have 30 degrees west of north and then 10 degrees south of west. Okay? So you're going to have compass directions. That's going to bring trigonometry in. Okay? So Unit 1 and Unit 2 involve a significant amount of trigonometry. Okay? Using sine, cos, and tan and all that kind of stuff. Okay? So if that's something that scares you, know on the first day there's a significant amount of it in Units 1 and 2. Okay, just putting it out there and being honest with you. It's not hard, okay? I'm just putting it out there and being honest with you. There's a significant amount of trig in Units 1 and 2. Okay? All right, so like we said, we've got the graphing stuff and then the vector addition, and then at the end of the unit we have projectile motion, which kind of ties everything together. That unit will take us up to second or third week of March. Okay? And we have that week off in February, so somewhere in there. Okay? Then after that, we get into the longest and what typically ends up being the most difficult of the units, and that's dynamics. All the same kinds of motion that we learned in Unit 1, but instead of looking at them from a velocity and distance and time perspective, we look at them from the perspective of the forces and the work and the energy that cause them to happen. Okay? So it's all about Newton's laws, first, second, and third laws. Okay? Work energy theorem, which is review from Science 10. Conservation of energy, review from Science 10. Okay? But we take those concepts a little bit further, but they should be familiar to you from Science 10. Okay? That unit should take us to after Easter, more than likely, so middle to end of April. Okay? Then circular motion and gravitation, shortest, easiest unit. Okay, about 3 weeks long, so it takes us to about May long, middle of May, somewhere in there. Okay, and then our last unit is simple harmonic motion and waves. Okay, and that one will take us up to the end of the semester. Okay, and in that one we talk about like pendulums and springs and waves. Okay, and then unit 3, we talk about circular motion. We talk about gravity, how gravity works, how satellites orbit, things like that. Okay, so those are your 4 units for this course. Okay, your marks distribution. Your unit exams, okay, 4 unit exams, are worth 45% of your final mark. Okay? Your labs and assignments and projects are 20% of your final mark. Your quizzes, and I haven't talked about those yet, but your quizzes are 10%. Here's how quizzes will work. Every Tuesday and every Thursday, with the exception of tomorrow, okay, you will have a short quiz. Take 5-10 minutes. Okay? I will post Mondays and Wednesdays a practice quiz for you to do. Okay? That practice quiz will be very similar to the quiz you will write in class the next day, so you'd be advised to actually do it. Sometimes it's even the same quiz. Sometimes I get lazy. Okay? Sometimes I actually post the real quiz that you'll do. All right? But it's in your best interest to try it at home and then come in the next day and write the quiz and do fine. Okay? It's only 10% of your mark, right? And you're going to have 2 a week for the entire semester. So each quiz is not worth very much, like 0.25% of your final grade by the time it's all said and done. Okay, so 1 bad quiz, no big deal. 40 bad quizzes is bad. Okay, don't want that. Okay, just make sure you're prepared for this.
So are we gonna have one on Thursday?
Yes, yeah, you'll definitely have one Thursday. You won't have one tomorrow. Okay, and then your final exam, 25%, so end of the semester in June. Unless, of course, something happens like happened this semester and it ends up being no fault and then all the weight just shifts to everything else. Okay, which is what we had to do last semester. All right, any questions on any of that? Okay. Then, if you can take out your notes package or call that up on your phone, Unit 1, Lesson 1 is what you need right now. So I'll give you a minute to find that and then we'll get started. Okay, so guys, since I give you the notes package ahead of time, you're probably gonna find that if you're trying to copy the notes down on paper as we go, you might find I go kind of fast, and that's simply because you have access to everything that's on the board, okay, already. So if you're physically writing it down, you might find that you fall a little bit behind, okay? My suggestion would be, in that situation, take a picture with your phone, okay, of the screen, and then you can just insert that picture into your notes package later, okay, if you find you're running falling behind, okay? All right, so the key points in every lesson in your notes package will look like this. It'll say the lesson number, and then there'll be key points underneath. Those key points are there simply to help you when you're going back to study. Okay, you can review, you know what things are important, okay, in that lesson. So in this lesson, okay, we need to understand that the motion of objects and systems can be described in terms of displacement, time, velocity, distance, speed, okay, those things. So V equals D over T basically, okay. Make sure we understand the difference between scalar and vector quantities is point number 2, and define velocity as a change of position, during a time interval. In other words, V equals final position minus initial position over time, or D over T, okay? Displacement divided by time. So we'll be working on that, but that should be familiar to you from science 10. Okay, questions so far? Okay. So we have this problem in physics. And the problem is this. In North America, we have a really messed up way of communicating how far away places are. Okay? It's a cultural thing. And it's because of the way we typically get from one place to another. Right? If I want to go to Edmonton, I get in a car. I get on the road, and I follow the road to Edmonton. Okay? How far is it to Edmonton?
3 hours.
3. Okay, so there's the 2 answers. Usually that's the one I get, is the 3 hours, because that's how we think. Okay? As North Americans, when someone asks how far away something is, we think they want to know how long it'll take to get there. Because that's really what they want most of the time when they ask that question. Very rarely do they actually want to know it's about 300 kilometers from here. Okay? That is how far. That's what I asked. That's actually the right answer, 300 kilometers. Okay? Because I asked, how far is it from here? Okay? When we say 3 hours, that's not how far it is. That's how long it takes to get there. But that's how we think. Okay? And it's okay, you don't have to put up your hand, but I know that most of you are probably thinking 3 hours. Okay? That's just how we think. Okay? It's not physically right, but it's practically right. It works. Here's the problem with that. It's not always 3 hours. Okay? There might be a couple times a year where you could drive to Edmonton and it would actually take you 3 hours to get there. Right? Because there's all kinds of things that can change that number. There could be traffic in Calgary. There could be a snowstorm. There could be a thunderstorm or a tornado or a road construction. Because, I mean, really we have 2 seasons here, right? Winter and construction. Okay? So there's always something to slow you down. Okay? And so very rarely do you ever get to actually drive the speed limit all the way from Oakville to Edmonton. Okay? So it probably takes more than 3 hours most of the time to get there. Okay? Because that number, the time, is dependent not only on how far Edmonton is, but how fast you can go. Okay? How far Edmonton is isn't dependent on anything other than the route I take to get there. Right? So as long as I take Highway 2, Edmonton is always the same distance from here, unless the continent cracks open in the middle. Okay? Everybody okay with that idea? Not the continent crack open, that won't happen. All right. So, like we're saying here, if you go hiking off trail or done any orienteering, you know that the way we describe travel in everyday life is really bad. Okay? It works for us because we're familiar with the area, and when you tell somebody, oh yeah, if you wanted to get to Walmart from here, it's like 5 minutes, 10 minutes, no problem, right? Like we just know that because we're all familiar with the area. Somebody pre-COVID gets off a plane and comes in here and says, well, I need to get someplace, and you go, oh yeah, it's 2 hours from here. They're gonna go, oh, that's nice. Which way do I go? How far do I go in that direction? Because they're not familiar, okay, with the area, so they don't know. Okay? So the way we typically describe things in a familiar setting doesn't really work from a physics perspective, and in fact, it's wrong. Okay? If I was to give you a problem, okay, for you to solve, and I asked, how far is this thing away, and you wrote 3 hours, that's not what I asked. Okay? You gave me how long it would take, not how far it was. Okay? So we have to make sure we kind of change our thinking a little bit, okay, when we're doing stuff like that. Right? But it comes up a lot. Okay? This whole idea of us giving a time when we actually want a distance. It can really mess people up. I had a time where I was backpacking with a friend of mine in Kootenai, and we had this really long day. It was like 35 kilometers long and a couple of passes. It was like 4 o'clock in the afternoon. We were out of water, hungry, tired, and we weren't to where we were supposed to make camp yet. And we were starting to think we might have gotten lost. Okay? We kept looking at the map, and we were pretty sure we were where we thought we were, but we weren't where we were. Right? And we couldn't figure out why we weren't at the campsite yet. So we kind of sat down, and you're trying to think, but you're dehydrated and hungry, so you're not really thinking straight. And then we noticed this guy who is like bounding up the mountain towards us, okay? Up the mountain. And he's literally bounding, like he's running with a 60-pound pack on his back, running towards us. And we're like, oh, sweet, this guy will know. So we're like, hey, dude, like, where's like Tumbling Creek Campground? He's like, oh, mate, it's just down that way. Okay, it's like 20 minutes. I'm like, sweet, it's 20 minutes. An hour later, we are talking about how we're going to drop our packs, hunt this guy down, and beat the ever-loving you-know-what out of him. They're telling us it was 20. Like, that could happen. The guy was running with a 60-pound pack uphill. We're two out-of-shape teachers on their summer vacation walking downhill. Okay? What took him 20 minutes took us over an hour. Okay? So we're cursing this guy, we're filtering water, getting something to drink, finally getting something to eat, and then we're starting to think straight, and we're like, man, we just did what we told our students not to do. We listened to a guy who told us how long it took him to do something when we asked him how far it was. How dumb are we? Right? Sure, of course, he was probably, like some Australian Special Forces guy who was just out for a jaunt, okay, as opposed to two out-of-shape teachers on their summer vacation, okay? Yeah, of course he's going to go faster than us, but we didn't take that into account. I mean, at the time, right, he was running. And we didn't think about that till after. We were walking, well, stumbling because we were so tired and dehydrated. Okay, so telling people that is really going to be misleading. Okay, it's not that it wasn't accurate. It was perfectly accurate for him. It just wasn't accurate for us. Okay, so we have to always be mindful of that. Okay. Now, people get this idea that a vector quantity and a scalar quantity are different because one is more accurate. Okay? Well, I'll fall asleep with that elevator. Okay, so it's actually not true. Accuracy comes from how you measure something, not whether it includes a direction or not. Okay? Obviously, a scalar quantity doesn't include a direction. Okay? So if somebody asks me how far it is to Edmonton, I say 300 kilometers and I'm done. Okay? It's 300 kilometers from here. If I give them a vector description of that, then I say it's 300 kilometers north of here. Well, those are equally accurate. They're both measured to the nearest kilometer. Okay? One is more descriptive, but that doesn't make it more accurate. Accuracy depends on your measurement. Okay? Had I said that Edmonton is 301.5 kilometers from here, and then 300 kilometers north, the scalar version would actually be more accurate because they measured it to a half a kilometer as opposed to the nearest kilometer. Okay? So in that case, I can have a scalar quantity that's more accurate than a vector quantity of the same thing. Okay? It just depends on how I measure it. All right. So saying Calgary is 40 kilometers away, 13 degrees west of north is a vector description. Just saying Calgary is 40 kilometers away is a scalar description. Anyone follow the difference? And scalar quantities have just magnitude, vector quantities have magnitude and direction. So, quick review from Science 10 here. Okay, scalar quantities would include distance. How far is this thing from here? Okay, how far did you travel? Okay, how far always refers to distance. Okay, if someone asks, what's the change in position, or how far and in what direction, then they're asking for a vector description of an object's displacement. Okay, that's a vector quantity. Change in position is how far you've moved and in what direction from your starting position in a straight line. Okay? Distance is not always a straight line. Okay, I'm going to show you an example of that in just a minute. Okay. You're driving down Deerfoot and you get pulled over by the police because you're going too fast. What do they ask you? You know how fast you were going? Okay. Do they want your speed or your velocity? They want your speed. They don't care what direction you're going. Okay? They already know how fast you were going. They're just checking to see if you knew how fast you were going. Okay? Speed is scalar. That's why the sign says speed limit. It doesn't say velocity limit. Okay? It says speed limit. It doesn't care what way you're going, just how fast. Okay? If you're going too fast, then you get a ticket. Okay? So that you tell them their speed when you get asked that question. Do not tell them this. Okay? If they say, how fast are you going? And you say 130 kilometers an hour at 13 degrees south of west, there will be a follow-up question. And how much have you had to drink today? Okay? Because that's a weird answer, man, to that question. Okay? So no, they're not, you don't want to tell them that. Okay? Just tell them how fast you're going. They want your speed, not your velocity. Okay. Time. Time is scalar. But again, this is a North American thing. We talk about it like it's not. How far is Edmonton from here? It's 3 hours north. Time doesn't have a direction. Okay? Time is how long it takes to do something, not which way time goes. Time doesn't go north. Okay? Time goes forward. That's it. Unless you know something I don't. If you got a time machine at home, let's talk. Okay? A few things in my life I do differently. Okay? All right. So time is a scalar quantity because it doesn't go sideways or backwards or anything else. Okay. Other scalar quantities, not that we'll need in this unit, okay, but other scalar quantities, work and energy, are also scalar quantities. I think that'll be more unit 2, but they're scalar quantities as well. Okay, and one last one. Mass. Okay, how much of you there is your mass. That doesn't have a direction, it's just how much of you there is. Okay. All right, so these are our, we got one more here for this unit. Acceleration. Acceleration is a vector quantity. You are either accelerating positively, which means you're going faster, or you're accelerating negatively. Either you're going slower or backwards. Okay? But acceleration is a vector quantity. Okay. And for next unit, so is force. Okay? If you push or pull something, you push or pull it in a certain direction, so it's a vector quantity. Okay, here's another thing we as North Americans screw up all the time. Force and mass. Somebody asks you how much you weigh, you tell them something in pounds or kilograms, right? That's not how much you weigh. That's how much of you there is. Kilograms and pounds measure mass, not weight. Okay? Weight is the force of gravity pulling on your mass. Okay? It is a force. It is what you would feel if somebody sat on you. Okay? You feel their weight, not their mass. Okay? Because if you went to the moon and that same person sat on you, it wouldn't feel as bad. Because they wouldn't weigh as much, but there'd be just as much of them there as there is here. Okay? Weight is a force. Okay? Which is why I play a joke on people when they ask me that. Because it's rude. You should never ask anyone that. It's a rude question. Okay? If someone asks me how much I weigh, I tell them I weigh 775 newtons. And then they chuckle awkwardly and usually leave. Okay? And that's good, because not only did I not lie about what my weight was, I should have told them my real weight. Okay? I also teach them a lesson. That's a rude question. And weight is a force, not mass. Okay? I tell them how hard gravity is pulling on my mass. How much you would feel if I stood on you. Okay? That's what I tell them. That's what my weight is. Okay? But we get that one wrong in North American society all the time too. Okay? All right. Moving on here. So let's illustrate with this example here the difference between or look at a trip from two different points of view, from a scalar point of view and a vector point of view. Okay, so it's the same trip. So I have this theoretical journey from my house to Walmart. Right, now you'll notice that I'm not showing you where I live because nobody lives southeast of Walmart. It still lives in town. Okay, this is fictional, so you don't know where I live. All right, so I'm here and I have to walk to Walmart. I can't walk to Walmart in a straight line unless I live right behind Walmart, and I don't. Okay, so I can't walk there in a straight line. I got to follow the paths. I got to turn, go across the bridge, whatever. Okay, so I'm going to follow this path, this black line from my house to Walmart. The total distance that I would travel in black is going to be 4 kilometers. Okay, I can't put a direction on that. It's just how far I had to walk. Okay? And there's many. I walked in many different directions. Okay? Sometimes it was a little bit northwest, and sometimes it was north. Okay? It looks like there's one part here a little bit southwest even. Okay? I can't give a direction because there were a whole bunch, and distance is scalar anyway. It just cares how far did I have to go to get from A to B. That doesn't mean that Walmart is 4 kilometers from my house. It's not. In a straight line, Walmart is closer than that. Agreed? Okay, so in a straight line, Walmart is 2.8 kilometers at 38 degrees west of north from my house. Okay, that's how much I would be displaced, or how much my position would change in walking from my house to Walmart. If I had a helicopter, that's the path I would follow. Of course, if I had a helicopter, I sure wouldn't shop at Walmart. Okay? I could afford to shop at really nice places if I could afford a helicopter. Okay? So, that's my displacement. The straight line and direction of travel, okay, that's displacement. It's how much I change my position by. Okay, so displacement is change in position. Okay, distance is how far did you go. All right. Now, speed and velocity have a similar relationship. One is vector and one is scalar. Okay? If I want to calculate my speed, I need to know how long this trip takes me. Are you okay with that? Right? Because speed is distance divided by time. Right? So let's say it takes me a half an hour to walk to Walmart. How fast was I walking? Half an hour. Okay. So I walked 4 kilometers in half an hour. What's 4 divided by 0.5?
2 kilometers long.
8. Yeah, you multiplied by 1/2. Yeah. Okay, divide by 1/2, it's like multiply by 2, right? Okay, I mean, think about it. I walked for half an hour, I went 4 kilometers. I walked for an hour, I walked 8. Okay, so my speed was 8 kilometers per hour. No direction on that. That's just how fast I was walking. Okay, if I'd have been on a treadmill, it would have registered 8 kilometers per hour. Okay, even though I changed direction sometimes. Okay, now I want to calculate my velocity. What do I do different? Exactly. Yeah, I would use displacement instead. So velocity is a v with an arrow over top. The arrow denoting this is a vector quantity. It has direction. Okay, so we always put an arrow over top of any vector quantities. This is speed. This is velocity. Okay? So velocity equals displacement divided by time. We already said my displacement is 2.8 kilometers at 38 degrees west of north. Okay, so that's going to mean 2.8 kilometers at 38 degrees west of north divided by half an hour. Okay? It still took me a half an hour to change my position by that much. It took me a half an hour to get to Walmart. Okay? So my velocity is going to be smaller than my speed, agreed? And it usually is. In fact, velocity will never be larger than your speed. It can be equal if your trip is a straight line. That's the only way they can be equal, right? If your distance and your displacement are a straight line, okay, then they'll be equal. But displacement will never be bigger than distance. Velocity will never be bigger than speed. All right. So if I do this calculation, okay, the 2.8 kilometers, then I'm going to get that my velocity is 5.6 kilometers per hour at 38 degrees west of north. The direction has to be the same. Why? Could I go 38 degrees west of north if I traveled 5.6 kilometers per hour south? That's why they have to be the same. Okay? My velocity has to have the same directions as my displacement, otherwise I can't make one of them happen. Okay? If I'm traveling in that direction at that rate, my displacement's going to be in that direction and vice versa. Okay? So velocity and displacement will always have the same vector because they have to point the same way. All right, so that's the trip to Walmart. Okay, now we're going to talk about what happens when we go home. So I'm getting old. My mind's not as sharp as it once was. I get to Walmart and I realize I don't have my wallet or my phone. Because this summer I went to Walmart and I forgot my wallet. But I had my phone and I could use it to pay instead. But let's say I forget both because I'm getting old and senile. Okay? I'm not going to walk around Walmart for the fun of it, so I just turn around and walk home along exactly the same path. When I get home, it's another half an hour. What's my speed now? It's the same, yeah. My distance is now 8 kilometers because I went there and back, right? So I went 4 kilometers there, 4 kilometers back. Okay, took me an hour. My speed's still 8 kilometers per hour. Okay, that doesn't change. Here's what does change. What's my displacement now that I'm back home? 0. Okay, remember, displacement is your change in position. My starting position was home. My final position is home. I didn't go anywhere. I may have walked 8 kilometers, but I didn't displace myself because I ended up back where I started. So my overall displacement is 0 kilometers. So what's my overall velocity? 0. Okay? Velocity is displacement divided by time. We just said displacement is 0. 0 divided by anything is? Okay, so this is the difference between vector and scalar. Okay, when you start backtracking, vector and scalar can really change. Okay, distance and speed look at this trip in an entirely different way than velocity and displacement do. All right, everybody okay with that idea there? Okay, so if I want to have an instrument in my car that tells me how far the car has been driven, do I want it to show distance or displacement? Distance. Okay? I want it to show how far the car has been driven, regardless of direction. If that instrument shows the displacement of the car, every time I get home, what's it going to read? No, it's going to read how far it is from the dealership you bought it at to your house every time you take it for an oil change, and it reads 0. It's a trick question. Nobody's ever gotten it, right? Everybody goes 0 right away. Gut reaction. Okay, you're right. It would always read some small number. Okay, if you go back to the dealership, that'd be great because you're going to trade it in, and it's got no kilometers on it. That's exactly why it doesn't do that. Okay, it tells you how far you've driven the car. If it read displacement, I could have driven it to Tijuana and back a whole bunch of times, and it could have 250,000 kilometers on it. But it would read 0 when I got back. That'd be pretty sweet for me, but pretty bad for whoever buys it after me. Okay, that's why it doesn't do that. Scalar is appropriate sometimes, and vector is appropriate sometimes. Okay, and that's what we kind of have to get our heads around. We get this idea that because scalar doesn't have something, it's less useful, but it's not. Okay, there's lots of times where I do want something to be measured in a scalar fashion, and there are some times where I want it to be measured in a vector fashion. Okay, if I'm talking about driving cargo in a semi-truck from one side of the country to the other, okay, scalar is fine. I'm going to follow a road. That's great. But if I'm flying that stuff, I need vectors. Okay? In a plane, you don't follow a road, right? You just put it on a heading, and you go from A to B in a straight line. Okay? So sometimes vector is good, sometimes scalar is good. All right, everybody okay with that example? All right, so here's the situation. I'm hiking here. I want to go from Seldom Inn Campground to Snake Indian Falls Campground. just outside of Seligman Campground is a sign that says Snake Indian Falls Campground, 32 kilometers. Scalar or vector? Scalar. It tells me the distance to the other campground. Okay? Why is that appropriate in this situation?
Because it's how long, that's how far you go.
How far I'll go provided I do what? Follow the path. Exactly. That's what I should do because that's the smartest and safest route. Okay? That says 32 kilometers along this path. That sign would be crazy to say this. Snake Indian Falls Campground, 21.8 kilometers at 15 degrees north of west. Unless I had a helicopter, that is not a good way for me to go. Okay? These are big rivers. This is a glacier. Okay? So this is a big mountain here. This is not an effective way for me to travel from A to B. Okay? That's the smarter route. So in that case, it's better to have a scalar description. All our road signs work that way. Okay? When you come across those road signs that say how far it is somewhere, they never say a direction. They don't have to. Okay? Scalar is just fine in those situations. Okay, so this is what we were just talking about, so we'll just quickly go through this because we already did these calculations, the 8 kilometers per hour, the 5.6, okay, and then when we got back it was 0, okay? All right, so some definitions here, okay? Scalar quantities, okay? Any measured quantity that has only a value or a magnitude, 40 kilometers, 200 pounds, okay? 100 kilometers per hour, okay? Something like that. Those are all scalar quantities. Okay? Distance is an example of a scalar quantity, measures how far an object has traveled. Just how far, not which way, just how far in total. Okay? Speed, okay, scalar quantity that measures how far an object travels in a set time interval. Most of the time in physics, that's going to be meters per second. Okay? But more commonly, we use in real life kilometers per hour. Okay? Vector quantities are any measured quantity that has both value and direction, or magnitude and direction. So 40 kilometers forward, 3.2 kilometers at 18 degrees west of south, 9.81 meters per second squared down, okay? 200 newtons west, okay, something like that. Those are all vector quantities. Right? Displacement's a vector quantity that measures how far and in what direction an object has traveled from its starting position. So add to that one this. Displacement is final position minus initial position. That's how we calculate displacement. Okay, and then lastly, velocity is a vector quantity that measures the displacement of an object during a set time interval, or the rate of change of your displacement. Okay? In other words, how fast and in what direction you are going. Okay? Then there's some formulas down here, but you already know those. V equals d over t and v equals d over t. Okay? Not quite the same formula. One is velocity and displacement, the other is speed and distance. Okay? All right, I'm going to give you guys about a 5-minute break here because I've been talking non-stop since the start of class. So I'm going to give you about 5 minutes, and then we'll resume with a few kind of review type problems that should be familiar to you from science. Okay, so give you 5 minutes here. If you need to use the bathroom, now's a good time. Okay, need to answer any of your texts or anything, now would be a good time. Okay, 5 minutes, so be back at it at 1:22.
Like, that's good. I haven't done physics in 4 years, so that's good. You're 12:30 till so 3:30, right? Yeah. No. actually sick. I got lab next period, so. No, it isn't. Yeah, no, I'm here from 12:30 to like. Yeah. Oh, thank you. Yeah, so. Yeah. Yo, what's up? Physics. Yeah. I'm not full. Oh. Oh my god. Oh no. Yeah. See what what happens is
Did you take math last semester? If we ever
I wrote it, well, like
no, I remember.
Yeah, I guess it was Jack, but Jack had like a 98 in math last semester or something.
I don't get to school until like.
I think Eric had like a 96.
Just come see me at like 11:50.
That's crazy. I had a
Yeah,
I'll be at
alright. See you. See you next time.
Are you playing? Or like, are you? If that was nice to you. Oh yeah, usually. Are you gonna play basketball next year?
On Friday, yeah. I don't know if I might not be here.
Oh, might.
We got like football tournament.
Oh yeah. I'll miss you so much.
You too.
Yes.
Sign up for the team.
Oh, was it?
Even so.
I might, maybe. I don't know. I got nothing else.
You need all the patterns.
She just does
That's just your excuse for your
Are you committing today? He's done.
use a bunch of patterns.
Yeah.
It's like right now we want to. It's like come to one track.
Okay, guys. Let's get everybody's attention back up here now. Okay, so we're going to go over a few kind of simple problems like you would have had back in Science 10. Okay, and our first one here is just calculating displacement. All right. So what we have to remember about displacement is that formula that I wrote on the board, okay, just a minute ago, which is that displacement is your final position minus your initial position. Right? So in this question here, okay, they're telling us our final position is 3.5 meters left, and our original position is 1.5 meters right. Okay, because it says the traveler is initially standing 1.5 meters right of the Inukshuk. So that makes this our initial position. Okay, they move so that they are 3.5 meters to the left of the Inukshuk. So that means that's our final position. And they want us to find our displacement. Okay? So all we have to do is plug in our numbers. Now, one of these is left and one of these is right. They're opposite. How do I represent that mathematically? Negative and positive. Okay, so that means my initial position is going to be positive and my final position is going to be negative. So negative 3.5 minus positive 1.5. Okay, if I do that, I'm going to get negative 5 meters. Now, do I want to leave it as negative 5? No. What do I want to write it as? Left, right? Okay, because that's left. Correct, left. Okay, so we've got 5 meters left. Okay, we have to write the left because that's what the question gave us for directions. If we leave it as negative 5, it would be wrong because the question didn't give us positive and negative. We assigned those to the directions. Okay? And that's something that will hold true even when we start getting into the compass directions, the two-dimensional motion. North would be positive, south would be negative, and so on. Okay? All right, questions on how that one worked? Okay. Then I want you guys to try these 3. They work very similar. Okay? I'll give you a few minutes on those, and then we'll do them together. First one's pretty straightforward. All of the parts of this trip are all in the same direction. They're all north, so all we have to do is add them together. Okay, so we got 40 meters plus 20 is 60, plus 100 is 160 meters north. Would the distance be the same magnitude? Yes, it's a straight line, right? My distance would be 160 meters. My displacement is 160 meters north because it's a straight line trail. Okay, for question number 2, okay, to perform a give and go, a basketball player fakes out the defense by moving 0.75 meters to the right and then 3.5 meters to the left. Okay, so what I have to do is kind of arbitrarily mark the starting position for this sequence. Okay, first they move 0.75 meters to the right. Then from there, they move 3.5 meters to the left. Okay? What the question wants to know is, what's the displacement? That would be, what's the distance and direction from start to finish? Okay? So what I would have to do there is say that my displacement equals, okay, positive 0.75, sorry, final position, okay? Okay, when I do that, I'm going to get my 2.75 meters left. Okay, now you'll see that I drew this in a certain way, right? I drew it in the order it happened. This is how we draw all vector stuff. First I drew the 0.75, and then I said after that, so from this position, they've moved 2 here, then they go 3.5, then they go 3.5 meters from there. Okay, they didn't do this. Okay, that would be them going in 2 different directions at exactly the same time. Okay, so unless they like split in half, okay, they didn't do that. That's not physically possible, right? So whenever we draw vectors, okay, we draw them tail to head. Okay, that is, I draw my first vector, and on the head of that vector, I start the next one. Okay, so the tail of the second vector is on the head of the first. Right? And it gives me kind of a way to tell the story or show in what order the trip happened. Okay? It becomes more important when you start changing directions at an angle, okay, to draw them that way. All right, and then number 3, okay, we got a bricklayer who's sweeping cement back and forth with a trowel like this. Okay, just back and forth, back and forth. Each time they move the trowel, they move it 1.7 meters. So they start here, and they go 1.7 meters that way, and then they go 1.7 meters, and then they go 1.7 meters, and then they go 1.7 meters. Okay, if I want to calculate their total distance, what do I do with the 1.7 meters? Add them all up or multiply by 4, right? That'll give me the total distance that the trowel has traveled. Okay, but in terms of displacement, this is where I started, and this is where I ended, so my displacement is 0. My final position and initial position are the same place, so therefore my total displacement is 0. Okay. Everybody all right with that? Those are about as simple as they get, okay, in terms of calculating displacement and distance. Okay. All right. Now, having a reference point. A reference point is important. Okay? On all of these questions, we've had a starting point that was our reference point. You have to have that if you're going to outline how the trip works. Okay? So I want you to think about that when you're trying to draw and then calculate the answer to question number 4. Okay? One of the people in this seating plan is the reference point. Okay? You have to figure out which one if you're going to draw the seating plan correctly, and then figure out what a teacher's displacement would be walking from Greg to Hannah. Okay? So I'm going to give you a couple minutes on that one and see how you do. Okay, so on number 4, okay, the first thing they tell me is that Chad is 2 meters left of Dolores. Who's my reference point? Chad or Dolores? Dolores. I don't know where to put Chad unless I measure that from Dolores. Dolores, even though they never tell me where Dolores is, everybody else is either a direct or indirect measurement from her as the reference point. Okay, so I'm just going to put Dolores here. Okay, then I'm going to go 2 meters to the left of that, and I'm going to put Chad there. All right. The next thing they tell me is Ed is 4.5 meters to the right of Chad. All right, so there's 2 meters and then another 2.5 meters past Dolores would be Ed. Okay, still using Dolores here, but I also used Chad. Okay. Then Greg is 7.5 meters left of Chad. Okay, and Hannah is 1 meter to the right of Ed. So this is pre-COVID because she should be 2 meters away from Ed. All right, so now I've got all my distances, right? I know how far away everybody is. I can now figure out what a teacher's displacement would be if they started here and walked to here. All right, so they'd go 7.5 plus 2 is 9.5 plus 2.5 is 12 plus 1 is 13 meters to the right. Everybody all right with that? Okay, but if we didn't have Dolores as a reference point, would we have known where to put Chad? We wouldn't have. Okay, so we always have to have some sort of reference point to start our question from. Okay. Okay, I want you guys to try number 5. Okay, number 5 is going to involve the formula we talked about just a minute ago. Displacement is final position minus initial position. Okay, so read that one carefully and give that one a... All right, so in this question, what did they give me? They gave me the displacement. Okay, so they said that displacement is 50 kilometers west. What else did they give me? They gave me the initial position. Okay, 5 kilometers east. Okay, east and west are opposites, so one's got to be negative, one's got to be positive. Generally, west is negative, because if you do an XY plot, right, the left-hand side, which is where west would be, is usually negative. All right, so I'm going to say D is negative 50, initial position is positive 5, and I'm looking for final. So how do I get final position by itself? Exactly, I'll add the initial position to the other side. So what I'm going to have is displacement plus the initial position equals the final position. Okay, so that's going to be negative 50 kilometers plus 5 kilometers, which is going to give me negative 45 kilometers, which is 45 kilometers west. That would be my final position. Right? That makes sense. They went 50 kilometers, and they only ended up 45 kilometers west, then they must have started 5 kilometers to the east of that, right? Okay. Questions on that one? Okay. Try number 6. Super easy, but people don't think about it when they do it. They make a silly mistake. Okay? So you got these rackets, okay, which are made out of seal skin, which a lot of people probably like, but okay, they're made out of seal skin, and they are the people are standing 3 meters apart. Okay, child on the right, so that's this one, tosses the ball to the child on the left. Okay, and then they move 5 meters to the right to catch the ball again. Okay, determine the horizontal distance and the displacement of the ball.